All right, test acceleration. We're seeing an industry trend for an increased number and an increased density of efficiency maps. These maps are used to tune our controller. These maps are temperature dependent, and we end up needing different maps for every temperature, every battery voltage, different controls. We end up having tons of maps. And we're seeing another trend towards more density in the efficiency maps, which means more points of resolution. And then there's other tests as well. And what we have is, you take a torque and speed, measure efficiency, torque and speed, measure efficiency, and then you get this contour. And because of the number of maps, because of the number of points, and we're seeing people go to 25 maps or so, wanting to go to more. We're seeing people go to, thousands of points. They used to do hundreds, now they're doing thousands, and this can take weeks. So what are some sources of delay? And I won't read through all of these points, but you're making a lot of measurements with different data types, different numbers of channels, different alignments, and this is taking time to process. I've talked about cycle-based measurement. If you start measuring on weird periods for different instruments, you start seeing wrong results. If you start filtering poorly, you start seeing wrong results, and you end up ghost hunting because of your instrumentation. If you have errors, if you set a filter wrong, you might need to rerun tests. The machine heats up and it needs to cool down. We do these efficiency maps in a very fixed temperature, so you end up waiting on thermals. Each measurement point takes time, and when you're doing thousands of points, seconds add up. And then troubleshooting. Nothing ever goes right the first time. So there's many sources of delay in motor testing. Let's look at a case study that we did. We have a 9 second per point reduction. So we looked at a phase lock loop based method that takes 10 seconds per point. And then we looked at a cycle detect, which we put at 1 second. We could have done it faster, but we decided to do 1 second. And because of the thermal stuff, because of the transition periods of the dyno, we wanted to look at it rather than just saying 9 seconds per point, really look at what that would be. So we had 5 temperature states, 5 battery voltages. We had 25 maps. We did a 1 second measurement with cycle detect, a 10 second with the phase lock loop, and then we looked at the transitions. It was about 5 seconds per point, and then heating up and cooling down about every 100 seconds. We had a cool down for about 100 seconds every 60 seconds. And what we see is some pretty significant for 200 points per map, and at 25 USD per day, 2,500 USD per day for doing a testing house, you end up with about 17 grand in savings for that test at 200 points per map. If you go to 2,000 points per map, you end up with about 117K, and that's just the testing house. The time savings is huge too, like 600, 500 hours. That's really significant. So we're seeing really significant savings in time. We're seeing really significant savings in the number of test points, and we're seeing significant savings in money. So these are things to consider. And we offer feedback to automation systems. Because we do all our calculations in the real time, we can feed answers back to the automation system at 2 kilohertz. So as soon as you have your measurement, you can move to the next point, measure the next point, measure the next point, with a really nice handshake where we can feedback over EtherCAT CAN API at up to 2 kilohertz, and we can receive start, stop, trigger, change range, change reading over CAN, EtherCAT, LabVIEW, Python, or .NET, C#. We have an API. So real-time calculations and feedback allow for test automation, so you can test at the fastest rate, so you can save more time and more money.